Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. Friends, in this session again we have new project for YOLO8 custom object detection. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much and let's get started. So friends, as I mentioned, today we have again a new project for YOLO8. So first, just open Thony Python IDE as we always do a basic package installation. So just open Thony Python IDE, then go to the tools, manage packages, search for OpenCV-Python, then hit enter. It will search for OpenCV-Python first package, then click on install button. It will install OpenCV on our Windows machine. This is Windows 11. Of course you can use your Windows 10 machine also. Now Ultralytics package, Ultralytics, just hit enter, first package, click on install button, done. It will install Ultralytics on our Windows machine. Then CV Zone package, just search for CV Zone, first package, click on install button, done. It will install CV Zone on our Windows machine. So this is how we need to install first this basic package. So OpenCV-Python, then Ultralytics, and then CV Zone. So we have done with package installation. Now for today's session I have created a new repository, YOLO8 counting people in queue. So this is the name of our repository. I will mention the link. You need to simply copy paste the link inside the browser, then go to the code, click on download zip, and it will download our zip format repository. As you can see, we have successfully downloaded. So now just open folder, file manager basically, and then go to the downloads, and this is what our repository. Right click, WinRAR, and extract with the folder name. It will extract our repository. As you can see, we have now our folder. So again go inside the folder. We have again same name of folder, YOLO8 counting people in queue -main, and just click on the folder, and then we have our all files for project. So of course first we need our video file. So vid.txt, this is the text file. Inside that I have mentioned the video link. So vid.txt, just copy the link. This is basically mega cloud link. So just open Chrome browser, new tab, Ctrl+V, and hit enter. It will open our mega cloud link, and then simply click on download. It will download our zip format file. Inside that file we have our video file. So let's just first download our video file, then I will start video again. So friends, as you can see, we have downloaded our zip format file, and inside that we have our video file. So again go to the downloads, right click to cr.zip, WinRAR, extract with the folder name. So it will basically extract our folder. So just click on the folder, and this is what our video file. So simply we need to move our video file in same repository. So right click, cut, downloads, and our repository, again same repository, and then just paste video file. So friends, first let's just watch our video file. So this is what our video file, and friends, our goal is to create a counter for customer frequency. Simple. So this is what our scenario. As you can see, we have here two counter basically. This is the shopping mall center, and we have here two counter. So let's just say this is what our first counter, and this is what our second counter. So our goal is to count how many customer is basically right now on each counter. So simply for that, we know that we have a default object detection model for YOLO8 which detect a person, but I have already used the default model YOLO8 s.pt, and it's not perfect. It's not perfect working. So what we are going to do, we are going to create our own custom object detection YOLO8 model which only detect their head, or we can say their face. So our goal is to create YOLO8 custom object detection model which detect person head, and then it is really easy to detect our object and create the counter. Simple. So this is what our scenario. As I mentioned, our goal is to create a counter for customer frequency, or we can say create a counter which count how many customer is basically right now on each counter, or we can say simply crowd management. So this is what our scenario. Simple. So first we need images. So for images we have our img.py, and img.py which basically capture each frame from our video file itself. So here it is, as you can see, I have mentioned the video file name, which is cr.mp4, as simple as. And then for today's session we need 85 images. You can simply increase the number as per your requirement. I have mentioned 85 images is enough for this project. So 85 images, max frames 85. This is what our video file, and then cv2.imwrite is basically the code line where it's capture the image from video file and it will save image inside the folder. So first we need to create our folder. So let's just create our folder. So this is what our repository. Inside that, simply create a new folder, images. Simple. Just create images folder and then right click to the folder, copy as a path, and simply from this images folder, as you can see, just remove all the thing and press Ctrl+V. It will copy paste our folder path which we just created. As you can see, Yolov8 counting people in queue-main, and then we have our images folder. So here it is, as you can see, we have double quote. So just remove the double quote, and here also at the start line, here also as you can see we have two double quotes. So remove one. Now as you can see, the code line is in same color. It means there is no error. Simple. So here it is, friends, as you can see we have our images folder, and then we have person. So this person is basically the image name which we want to save. So it will basically capture 85 images inside our repository, and where we have our images folder, and inside that folder it will save image name with person, and the extension is basically .jpg. Simple. So let's just save our code, and if I run the code, as you can see, it started our video file. Done. So if you open our repository and if you go inside the images folder, here it is, as you can see we have 84 images. It means we successfully capture 85 images. Of course, the number 85 we mention here 85 frames, so it will capture 84 frames. That's it. So we successfully capture our images for our own custom object detection model. It is really easy. Now we need our label img software. So for label img software we need Python 3.8 version. So just go here, Microsoft Store, and then simply search for Python. So just search for Python and then Python 3.8 version. Just selected the version, click on install button, done. It will install Python 3.8, most easy way. So we have done with all basic steps. We install our packages, we have now our images, we done with Python 3.8 version. So now we need to simply change our version inside Tony Python ID. So go to the tools, sorry, not tools, go to the run config interpreter, and here we need to select this option, as you can see, this one, and then simply select Python 3.8.exe because we need our Python 3.8 version, and inside shell, as you can see, now we have Python 3.8.10 version. Done. Now simply open tools, manage packages, and label img. This is what our application name which we are going to use for labeling our images, label img, and just hit enter, application, or we can simply say a package. So label img and label img, and then just click on install. That's it. It will install label img on our Windows machine, which I have already installed. Done. Now go to the tools, open system shell, and let's just open our label img software. Label img, this is what command. Hit enter, it will open our label img software. As you can see, we successfully open. Now simply we need to select our images folder. So open dir, downloads, our repository, inside that we have images folder. Select it, again change save dir, downloads, our repository, same repository, and images folder. Done. So we successfully mention open dir folder and change save dir folder, the folder where we capture our images. Done. Now simply here we need to select YOLO and then create rect box, and as I mentioned, our goal is to detect person head. So simply draw a rectangle on person head and mention the class name people. Click on OK, create rectangle box, draw a rectangle box, click on OK, create rectangle box, draw a rectangle box, click on OK, create rectangle box, draw a rectangle box, click on OK, create rectangle box. Here also draw a rectangle box, click on OK, and then save it. Now if you open our folder, downloads, repository, same repository, and images, and inside that, as you can see, we have person.txt, and we have all our rectangle coordinates which we draw with the help of label img. So now simply go for next image, same way, draw a rectangle box, click on OK, create rectangle box, draw a rectangle box, click on OK, create rectangle box, then draw a rectangle box, click on OK, create rectangle box, draw a rectangle box, click on OK, create rectangle box, and draw a rectangle box, click on OK. So this is how, and then simply click on save. So this is how we need to draw a rectangle box on each person head with the help of label img. Simple. So I have already done with this process. So let me close label img software, and then simply in downloads, my training. So let's just first delete the images folder, because as I mentioned, I have already trained images. So let me delete images folder. So if I go back again, repository, as you can see, now there is no images because we deleted. Now inside downloads, I have here my training folder, and inside that we have images. Copy. If I go inside the repository which we clone, simply I am going to paste the folder and images, and inside that, as you can see, if I open, or let's just say, let's just open this images folder with our label img, hit enter, and then open dir, downloads, same repository, and images folder, select the folder. As you can see, as I mentioned, I have already trained all images with the help of label img. Here it is, as you can see, person class, and I have already draw a rectangle on their face for each image. As you can see, for each image I have draw a rectangle box on their faces. Simple. So this is how you need to draw a rectangle box on their head, and simply mention the class name person. Done. So we have done with our label img process. Now simply open our repository, and here let me close my training folder. So we have done with our label img process. Now simply here we need to create our freedom tech folder. So let's just create freedom tech folder, new folder, freedom tech. This is what our name of the folder, and again open freedom tech folder. Here again create two new folder, images and label. So images, again new folder which is labels. images and labels. And then now simply select one of the folder. So let's just select images folder first, and here we are going to create again two new folder, training and validation. So right click, new folder, and mention the name training, and then validation. So we create a two new folder inside Freedom Tech images. So first we create Freedom Tech folder, then inside Freedom Tech folder we create images and labels folder, and now we are inside images folder, and inside images folder we create training folder and validation folder. Again go back, same way go inside labels folder and create two new folder, training and validation. So right click, new, training, right click, new, validation. Done, training and validation. Now simply copy paste all our data from images, copy all the data from images, go back and go inside Freedom Tech, images, training, paste it, go back, validation, paste it, go back, labels, validation, paste it, then training, paste it. Simple. So this is how we need to copy paste all our data from our images folder to Freedom Tech, labels, training validation, and then Freedom Tech, images, training validation. Simple. So we have done with this process also. Now simply create a .zip file of our Freedom Tech folder. So right click, WinRAR, add to archive.zip, click on OK. It will create our zip format file. So we have done, we create our freedomtech.zip. Now simply upload our freedomtech.zip on your Google Drive. So this is what my Google Drive. Right click, file upload, downloads, repository, again same repository, and freedomtech.zip. Just click on open. So it will upload our freedomtech.zip on our Google Drive. So meanwhile simply open Google Colab, and inside the repository I have mentioned the training file for YOLO8. So click on upload, browse, downloads, and our repository, same repository, and this is what our Google Colab file. Click on open. So now it will upload our Colab file on our Google Colab. So friends, as you can see, we have successfully uploaded our Colab file. Now simply go to the runtime, change runtime type, select Python 3, T4 GPU, click on save, and then click on connect. So friends, as you can see, we have successfully connected. Now simply we are going to run our cell one by one. So let's just start with first cell. Then second cell, it will install Ultralytics package. So friends, we successfully install our Ultralytics. Now simply import our modules. Done. Now we are going to cross check if Ultralytics is perfectly working or not, means if Yolov8 is perfectly working or not. For that we are going to simply use online image from media.roboflow.com, and the image name is dog.jpeg. So click on the code, and then it will save our result inside our folder. So here it is. As you can see, it save our result inside runs, detect and predict, and object which we detect from the images is basically here. As you can see, one person, one car, one dog. This is the object which we have inside this image. So it means we successfully installed Yolov8 on our Colab. Now simply we want to mount our Google Drive. So click on the next cell, then click on connect to Google Drive, select your Gmail ID, click on continue, scroll down, click on allow, and now it will mount our Google Drive. So friends, as you can see, we successfully mount our Google Drive. We have our freedomtech.zip inside our drive. Now simply create a folder named Dataset, and inside that it will save freedomtech.zip. It will basically unzip all the data from freedomtech.zip. As you can see, we have person, image, and their text file. So if you click on the folder Dataset directory which we create and freedomtech folder, inside images, training and validation folder. So if you click on person JPG, and then here it is, as you can see, we have images. It means we successfully upload our images for training purpose on our Google Colab. So let's just close image. Now what we want to do, simply Freedom Tech, click on these three dots, just click on it, and then it will open this kind of menu. Click on new file, and we are going to create data.yaml file. Just hit enter. It will create empty file, data.yaml. Now double click on that file, and inside this data.yaml file, as you can see, it's open like this way. Here we are going to copy paste our code from our repository. Inside that I have mentioned data.txt text file. Copy the code, close all the things, and just paste the code over here inside data.yaml. And as I mentioned, we have only one class, which is person head. So simply number of classes 1, and simply we are going to change the name. So person, done, person. Then press Ctrl+S, it will save our code. Now we are ready, and we are going to simply start our training. So just click on last cell, it will start our training with 100 epochs. So friends, as you can see, it started our training 1 out of 100. So it will take some time. Meanwhile, I will pause the video. So friends, as you can see, we have completed our training, and our model is basically saved inside runs, detect and train folder. So just go to the runs folder, then detect folder, then train folder, and inside that train folder we have weights folder. Click on it, and then as you can see, best.pt. This is what our custom model, custom object detection Yolov8 model. Just click on here, click on download, and it will download our own model. So friends, as you can see, we download our model. So just go inside downloads folder, best.pt, right click, cut, and just move our model inside our repository, and then just paste it. So here we are going to create our coco1.txt file. So new, and then text document coco1.txt. coco1.txt is already there. coco1.txt, this is what our file name, and just open it and just mention our class name, which is person. File, save it, done. Now let's just open our test.py, and first close our img.py and untitled file. And because we change our version, as you can see, so we need to go with our default version. So just go here and select the first Python version, click on OK. Now we are Python 3.10, our main version. So here it is, as you can see, I have already mentioned best.pt. So this is what our test.py, where I have already mentioned the basic code. So if you don't know how to use Yolov8 with Python and OpenCV, I have already created a playlist, watch playlist, and then you will get the idea how to use Yolov8 with Python and OpenCV. So in test.py, I have already mentioned the object detection basic code. Here it is, as you can see, coco1.txt, the text file which we just create, and then this is the video file name, and here we have best.pt, our model, then we have our detection method, and then we have rectangle. As you can see, we have rectangle, then we have center point of a rectangle of our object rectangle. Cx is equal to int x1 plus x2 divided by 2, and cy is equal to int y1 plus y2 divided by 2. This is how we will get a center point. And then we are going to use here a new rectangle method, which is cvzone.cornerRect. For that we need width and height. So wh is equal to x2 minus x1 and y2 minus y1, we will get width and height. So then CV zone dot corner rect frame x1 and y1, then we are going to use width and height. Simple. And then we mentioned cx and cy. So with the help of cx and cy, of course, we can show the circle on our frame, on our object. So cv2.circle method, cx and cy coordinates, radius, color, and -1 for filling our circle. Then we are going to use cvzone.putText rect method, and we are going to put our person as a text on rectangle top left corner. This is the basic code for object detection. Simple. Now here, as I mentioned, we have our area, but let's just first comment our area method. Let's just only detect our object. So if I save the code, if I run the code, as I mentioned, this is what basic code. We have our own custom model. We mention our video file, and as you can see, there is a rectangle on each person head. Each person head, as you can see, we have rectangle. It means our custom object detection model is perfectly working. It's not detecting full person body, it's only detecting their head. Now it is really easy to create a counter. Here it is, as you can see, we only train 85 images, but it's working perfect. It's working for perfect, and it's detecting only the person head. Simple. So our model is ready and it's working perfectly. Now our goal is to create a counter. For that, as I mentioned, we need a region of interest area, ROI. Simple. So for ROI, we have our mouse event function. So mouse event function is here. As you can see, this is what our mouse event function. So if you move your mouse on the frame, inside shell we have coordinates. We have XY coordinates. So for this video, as you can see, our goal is to detect the person is basically in this area and in this area. Simple. So let's just move your cursor over here, and inside shell, as you can see, we have 547 and 75. So this is what my first coordinates. Then let's just say this is the second coordinates, 573 365. This is the third coordinate, 735 362, and this is the last coordinate. Then it will draw a polylines in this particular area. For this area also same, just move your cursor from here, then here, and then at the end here. Then it will draw the polylines in this area. So this is how I have mentioned the coordinates like this way. I have already mentioned the coordinates inside the code, so no problem. Here it is the coordinates for area 1, and here it is the coordinates for area 2. Now simply we are going to start our cv2.polyline method. It will use area 1 and area 2, and it will draw our region of interest area as a polyline. So I have started the code, and as you can see, there is a red color polyline which is our region of interest area. It means now we can simply create our condition. I just want to detect only the person if it is inside my selected region of interest area. Simple. So for this we have cv2.pointPolygon test method. So here, after where we have wh, after that simply we can say result is equal to cv2.point p capital polygon t capital test point polygon test. Inside that, what our condition? Our condition for point polygon test, we need area and we need a point. So for point we are going to use here their center point. So cx and cy. So area is basically this. So just copy as it is from np array to np.in32, copy as it is, mention over here. Simple. Then after that simply mention cx and cy, and then mention false. Now the result is basically 1 or -1. So if the result, if it is greater than or is equal to 0, then only we are going to draw a rectangle, the circle, and then we are going to put our text on the frame, on basically the rectangle. So if I save the code, if I run the code, and now as you can see here, there is no rectangle on other area. Here we not mention our area, here also we not mention our area, but because our goal is to only create a counter for customer, simple. So for that we draw our region of interest area here and here. So right now only we are going to mention a condition for this particular area. That's why here it is, as you can see, this person blue color center point is inside our area and it's detected the person, but this person will not create our condition. So let me start a while loop. If I start while loop, and now as you can see, this person is still inside our area, but when this person cross our area, there is no detection. There is no detection. So simply we can create a counter. So counter is basically the person center point. So this is what basically our condition. If the person, here it is, as you can see, this person is cross our area, now there is nothing. So our condition, if the person center point is, if it is inside our area, then only we are going to detect. So simply here, after our condition match, simply we are going to create our list with their center point. So list1 dot append, and what we are going to append? We are going to append simply cx, and here we want to mention cx, oh sorry, not cx, list. List is equal to like this way. And then if we go here, or let's just say here, because after that we are going to show our counter on the frame. So let's just mention here print, because we create a list, and inside that list, when the person center point, if it is inside our area, it will save there, or it will create the list of cx, list1. So simply we can mention this is the list1 with cx, the coordinate. So length of list is basically our count. So print length of list1, and if you start the code, now inside shell there is a number. There is a number for person. List1, let me check. Oh, I have mentioned here list. So list1 is basically the variable, because we mentioned here list1 dot append. So now it will work. So inside shell watch, there is 2. It means there is 2 person is basically inside our first area. Now there is 1. It means there is 1 person or 1 customer is in this particular area. Simple. So same way for second counter, let's just create a second counter condition. Same way, just copy paste the code from result to list1 and just mention over here, check it is in line. So I have copy paste the code. Now this is the result, and here it's in line. As you can see, it's in line. Only we are going to change the variable. So here we mention result. So here we are going to mention result1. So now if result1, if it is greater than or is equal to 0, and this is the condition for area 2, because we create area 1 condition. Now this is the condition for area 2. And let's just change center point color, because we mentioned cvzone.corner rectangle method, so it will not change their color. So we can simply change the color of center point, then we will get the idea. So here for area 1 we mentioned blue color, let's just mention here pink color. So 255 minus 1, then all things are same, and here list 1 we are going to create list 2. So mention here list 2 and like this way, and then simply now we know what we have inside our list. So simply we are going to show our 2 list counter on our frame. So let's just say here cr1 is equal to our length of list 1, and then CR2 is equal to length of our list 2 for area 2. Now simply copy paste the CV zone put text method, mention over here, and then simply, or let's just say cut after polylines, we are going to mention our counter method. On our counter, we are going to put on our counter on the frame. So CV zone put text rect method, and then the variable, let's say counter1. For counter1 we have CR1. So what else you want? We want to mention here, this is the variable counter1. After that, inside like this way, inside curly braces CR1, which is our first counter, CR1. So we have done with our counter, and then we need to mention here the frame coordinates where we want to put our text. So let's just say 50, 60, and then just copy paste the code, and then mention a second counter, which is counter 2 inside the curly braces. Simply mention CR2, then 50, 160, let's say, and simply we are going to change rectangle size, also the text size. Now we have our wait key 1 means we start our while loop. So simply save the code. If I run the code, and now as you can see, we have our counter 1, we have right now 2%, so 2 is there. Counter 2, we have only 1%. As you can see, there is a 1. So here it is. As you can see, it's little bit changing because of our model. So now as you can see, it's frequently showing only 1. Now on the counter 1 we have 0%, or we can say simply 0 customers. So here it is. As you can see, now we have 2 customer. So the first customer is cross our region of interest area. Now we have only 1%. So it's basically counting the person who is basically inside our region of interest area. So if this region of interest area, if there is a 2% or if there is a 3%, it will simply put that counter on the frame. As you can see, for this area we have 1, but on counter 1 there is no customer, so 0 is there. Simple. So here it is. As you can see, there is another customer is basically coming inside this particular area, and it's detected. As you can see, it's detected. Now there is on counter 2 we have 2%. So now here it is. As you can see, 1 customer, counter 1 we have 1 customer, and counter 2 we have 2, 1, because of course there is a movement. So if the person cross our area, of course there is no counter, but here it is. As you can see, it's perfectly working. Our model is perfectly working, is counting the customer inside our selected region of interest area. As you can see, there is 2, so we have 2, and here it is, we have 1, we have 1. So this is how, friends, you can create your own custom object detection model for this kind of project. I hope you learned something from this video. I have mentioned the code inside repository. We'll meet our next video. Till then, thank you, take care, and bye bye.